Right, this video is all about these worm gears. Now I know there's lots of videos on YouTube already about cutting worm gears with a tap. I've got to say a helical tap could be better, because this gear was alright because I was using a different tap. I was using a 3/4 inch 10 TPI tap, but the actual thread that I need to cut for a project that I'm doing, which I'll explain later on in the video, possibly something that's going to come up in the future, I need 8 TPI. Now the only tap that I've got, I don't like spending money if I don't need to, if I can work around something. The only 8 TPI tap that I've got within reasonable, I mean it's a little bit overkill for the project that I want to do, is an 8 TPI 1 inch 8 TPI tap. Now I need a particular spacing between the teeth for a 60 tooth gear. I need either 8 TPI, which works out at 3.175mm, or or a 3mm pitch tap, or 3.5 at the most. Now I've got an M33 3.5 tap, but that's even bigger than this. So anyway, nudge the camera tripod. This gear was cut with this tap, obviously, and what I did was I turned the diameter of this so the circumference is bang on right for the amount of teeth that there needs to be at that pitch. Because 10 TPI and I wanted 40 teeth, so I worked it out. I'll show you a bit of calculation as well. I worked out the exact diameter that I needed. So when it started to cut, it was nice and smooth and it was beautiful. It was cutting like a knife through butter. Now when I did this one, you'll see I ran into problems in the video, and it's something to expect. I mean, you could do a bit of a better setup than me, because it was rattling a little bit on the arbor, but it was skippy. It was doing this quite a bit, and for the simple reason, it's a bigger tap. The distance between the actual teeth, the flutes, the unthreaded section, is huge. I don't think I fed in enough with that. With the smaller one, I fed in quite a bit for the first cut, and the first cut was quite deep. So as this flute's about to exit the cut, this flute was about to bite, or just about to bite, and it was going around really smoothly. This one, I cut the diameter too wide on purpose to see what had happened with the actual cutting, and as I expected, it was skipping quite a bit, and it was a very rough cut. You'll see in the video anyway. But as I was getting deeper, as I got 2mm into the cut, it started to track properly, and for the simple reason, the 2mm in is the actual diameter that's needed for a 3.175mm or 8 TPI pitch. But yeah, like I say, there's a lot of videos, but all the videos that you see on YouTube, they don't show you any details. They just show you actually cutting it. So I hope you get something from the video, even if it's what not to do. Right, this is a setup. Start from the back, where what you can nearly not see. This tip here is a tip of an indicator, so I can indicate the carriage. It's an imperial lead screw. It hasn't got any divisions on it of any sort, so I indicate with a dial indicator. That's obviously the cross side. It's not being used. It got used to turn the blank, the diameter on the blank, which I'll explain how I got the dimensions either after this bit or before. I don't know how it's going to be organised yet. Typical of me, I can't organise anything really. This is a hand turning rest base that I made quite a while ago. Well, I don't use it that often, so I've used it for this. I've turned this stud to hold the blanks, and the blank is free turning. Now I've turned this one already, and when I was turning it, the cut is going down. You don't really need this washer. If you've got a few to do, instead of undoing this lot, put another one on, tighten it all up. What I found anyway, you don't necessarily actually need that. You just drop one on, cut it, take it off, drop another one on, it's cutting down anyway. If you're using a left hand tap, obviously you do, because then you're going to be cutting the other way around, it's going to flick it off. Anyway, that's the setup. I haven't moved it into position yet, but that's going to be the next step. Right, onto the diameter. To cut a proper worm gear, you need to know the pitch circle diameter. That's and various other formulas and measurements and dimensions. If you want to make a proper worm to use for power transmission, for like a dividing head or a rotary table, that kind of thing, for a milling machine. So you've got to be powering a table or chuck while the milling machine's doing the work, cutting material away. Now all this is going to be, and more than likely what a lot of hobbyists are going to be doing, is making a dividing attachment for the headstock of a lathe, and that's all it's going to be. So all you're going to be doing is dividing, locking the spindle if necessary, and then doing a little bit of work, say drilling a hole or scoring a line on something, dividing again, and then doing a bit of work. So it's not actual power transmission, so you don't have to be so critical. Now someone on Facebook says to me, do you have to be critical on the actual diameter of the blank for the tap that you're going to be using? And yes and no. Yes, if you want it like this one that I've cut, this one I've cut already, and the diameter of that, I made it perfect for the tap that I was using. At the time I was using a 3/4 inch 10 TPI, so I worked it out for the diameter that I needed. This one however, I'm going to, because I don't know 100%, because you see these videos on YouTube, loads of videos everywhere, and they don't give you the details. Now this blank is too wide for the pitch of the tap. The tap that I'm using is the tap that I'm going to be eventually using for the project. It's a 1 inch 8 TPI. So the way I worked it out is, I'll read it off a piece of paper or back of some sandpaper. I always try to convert to metric because I'm a metric boy. Basically, imperial is reserved for miles an hour, cars, distance, drinks as in pints, that kind of thing. Everything else metric. But anyway, 8 TPI is 3.175mm between each tooth. I want to make a 40 tooth gear, so 3.175 times 40 is 127. So that's the total circumference that needs to be exact. Now if you divide that by pi, you get 40.42, and that's the diameter. So if I was to cut it exactly the same as that one, I would turn that diameter to 40.42mm diameter. Then I know that that tooth pitch, when it's cut to the 40th tooth, the tooth of the tap will fall straight into the first gash that was made. Now what I want to do is I want to experiment. Say you wanted to add a pitch, cut it to a pitch circle, so the actual pitch circle needs to be the right diameter, and then you've got surplus on the outside, so the blank is actually wider than the pitch circle, which is how gears are cut. So I've added a little bit onto the side, but or left a little bit on, should I say, not, you can't add material onto material. But the actual diameter, instead of it being 40.42, it's 44.42. So I've added another 4mm on. And that 4mm, it's, if you work on the radius, an 8 TPI tooth is approximately 2 millimeters. 2 millimeters total depth approximately. So I've just added 2 millimeters onto the radius, which is 4 over the diameter. Hopefully I haven't lost you so far. But anyway, that's going to answer the question, what will happen if the diameter is not right for the tap, for the person that asked on Facebook. And also it'll answer it to myself as well, because I don't know. So what I'm going to do is, I'm going to feed in now. Enough talk, I'm just going to get another bit of recording done. Right, what I'm going to do is I'm going to feed in just so it touches. Right, something's off centre. More than likely the actual tap in the chuck. I'll correct that later by manually indexing. Right, I'll zero the indicator. I'm going to straight away feed in 0.5 millimeters. I'm going to stop when it comes halfway around and mark it with a pencil. Carry it on, and then when it gets to about just as it's going to cut, I'm going to stop it, pull it away, turn it round and see what's happened. I know what'll happen. Right, so 0.5 mil. This juddery at the moment, as obviously it's not a spiral tap, it's a standard tap. So you've got a lot of, a huge part of the tap that isn't actually threaded, so it's not going to be turning it. Right, I'll mark off, it's a little bit ragged, just here, but that is the first tap, the first thread, first gash should I say. Pull it away that 0.5 mil, turn it round and see what's happened. I don't think it's going to be that evident, because it's a bit of a mess at the moment. Right, it's not matching up anywhere really, it's a lot of right, it's not very good. Let's see. This is a very good video, isn't it? Feedback in that 0.5 mil. I'll just keep on going. See what happens after 2 millimeters. Right, picked up the track. Right, proper professional. Right, I know what happened there. You wouldn't have seen that. I turned with something with the lathe on back gear, and I didn't tighten the nut properly to pinch the ball gear to the pulley. So it snagged a little bit. The pulley kept on going, the ball gear slipped on the pulley. Right, feed back in. Come on. I'm being too impatient, that's what it is. Right, I paused it because I was worrying a little bit, because obviously, like I mentioned, it's the first time I've done this with a pitch circle. That's well, the second time I cut a worm gear, but it's the first time I've done it with a diameter that was too wide for the amount of teeth, like I've described. Now I've gone 2mm in, it's starting to form the teeth properly. It was jumping about quite a bit. It's still a little bit of a mess on the just on the peripheral of the where it's been mistracking a little bit. You might be able to see it there. You got a gash there where it didn't track right. It should have been there. So it definitely doesn't like it. But now it's got to approximately the depth, so it's about 2mm in. 2mm in is the actual diameter that it should be for the tip of the teeth to cut it exactly evenly distributed. So I'll carry on cutting, and I'll go in 1/4 millimetre at a time. Using a tap this big, obviously it does help as well if this washer here wasn't so high. Right, so I'll wait till that mark on the top, that pencil mark that I made, is level. I'll 1/4 in. That's a lot smoother, isn't it? It's not jumping about now. Because by the time one of those teeth comes round, by the time one of these flutes comes around and is just about to escape off the blank, the other one's engaging, so it's feeding it nice and smooth now. Right, mark's come round, go another 2 in, sorry, 1/4 in, 0.25mm in. I'll fast forward this. Right, that's cut. It's a little bit further than what I originally was going to cut. Nice to see if I could go deeper. The problem is, the deeper you go, if you just carry on going, the actual bottom, the centre section, will be cut away completely, so to be smooth. Because obviously, the further you go in, the tips, the further you go in, it wants the teeth want to be finer, close together, but they can't be because the teeth, the distance between each teeth, the tooth pitch is fixed. So the teeth will just end up cutting away all the material in the middle, and it'll only be the outside, the outer perimeter that'll have teeth, and the actual webbing of the tooth as it goes down. I don't know what the hell it's called, but you know what I mean. You should know what I mean, well, hopefully. The webbing of the tooth will get thinner and thinner as it goes down towards the middle, to disappear and then to start to come back again. Now, another thing that of note, if the tap is not 100% concentric, only one of the flutes, one of them out of 4, will be cutting at the depth that you want it to be, or the rest of them won't be cutting as deep. So every 4th tooth will be deeper than the rest of them. So yeah, one will be deep, the next one line will be shallower, the next one line will be shallowest, and then slightly deeper, and then deeper again, if you get what I mean. So the way to counteract that is to get the tap so it's approximately half level. Doesn't matter which flute. You back it off. Now what you've got to do is you've got to indicate, obviously, so you know where your 0 is. You don't want to lose that position, because you don't want to end up having teeth deeper than you want them all evened out. So I set my indicator, I'll back out. So it's 1, 2, 3, 4, 5 mil, and I'll turn the gear blank by 1 tooth. The gear blank, you know what I mean, the gear by 1 tooth, and then feed it back in 5 mil. 1, 2, 3, 4, 5. Turn the lathe on, do a couple of turns. So it's kicking up quite a bit of material. So it's chopping away material that it couldn't do before. That's a couple of turns. I wait till that mark what I put on it comes towards the tap. Back it off 5 mil again. 1, 2, 3, 4, 5. And I can index it easier because that mark lines up smack between 2 teeth, so I'll just put it between the other 2 teeth. And when you feed it in, that will then rotate to the position it wants to be in. 1, 2, 3, 4, 5. One, 2, 3, 4, 5. One more go. That's the worm gear hopefully cut. And that's a lot of deburring. So I'll come back to that. Right, the gear is still on the same mandrel, the arbor that I had in the hand tool rest base. It's now in the collet chuck. I've tightened it on because I put another washer between, so it's now tight, it's gripped, so as the lathe turns the gear's going to turn, and now it's down to deburring. So there are some nasty burrs in there. The outside's going to be easy. But this is just a lathe file. That's got rid of the burrs around the outside, but the only problem is, you might not see this because this camera that I'm recording on is not fantastic for this type of work. But on the inside of here, you might be able to pick one out. We get this real thin webbing between the teeth. You get some very fine burrs that are kicked up. Now the only way to really get rid of those is to go in there with a needle file, or with I can't remember what they call them now. Really fine diamond files, curved in all different shapes that you can get. Because that's a nightmare. You're not going to be able to go in there with a normal file, obviously, because otherwise you'll just rip the teeth to pieces. Don't think about getting a round file either. I've thought about that. See if I can find one. Yeah, I don't think about going in with a round file either, with the lathe on and doing that, because you'll just tear those thin teeth to pieces. So the only way to do it really is an idea that I've only just come up with, is to get an 8 TPI screw in the lathe and arbor it back up again and push it in, and the teeth of that steel gear, steel rod or thread, whatever you've got, should wear these real fine wispy mofo burrs off. So if I can get one, I don't think you're going to be able to see them. Just trust me, they're there. So I set it up now to hopefully have them worn off, and that will be a good experiment as well. Right, it's actually working. This threaded rod I've got is off an old wood lathe. It's an accessory for a wood lathe for turning, it's like a huge long 8 TPI arbor with a Morse taper 2 tang on it, and get my words right in a minute. But this is actually working. You might be able to just see here as I flick it, this little brass shard that's come off there. Not be able to see it. I'll just look at the back of the camera, see it. Yeah, you can. That's just been ripped out. What I've done is I've just stuck the lathe on reverse now, so it's flicking the burrs upwards, so you'll see them rather than them falling down in the shadows. Put a bit more power on, a bit more pressure. And it's pulling all little fragments out, all little burrs. That is absolutely gorgeous. That's absolutely gorgeous, that is. Can't actually see any burrs in there. More than likely will be some. Very, very fine. So it's to be up to you when you're doing your worm gear how much pressure you add, and how long you have it running for. I'll just zoom out so you can see the setup. It'll probably go out of focus. And that's that part I'm talking about the was taper. Take it out of the chuck, just loosen it. You can see we've already robbed a section off the end for something. But this is when I make the dividing attachment for that lathe. I'm going to have the worm wheel. I'm going to have the worm wheel on this, on the spindle itself. Rig up a mount on the inside and have the dividing head spindle sticking out at the side. You can tell it's British because at that angle there it's bang on 55 degrees. And I know that because I'm using the 3D software at the moment to design it, and I want it sticking up that way, but I'm designing the actual spindle of it itself, so I want it vertical in the software. So I linked it to the actual model of the case that I made, rotated it, and it was bang on 55 degrees to get the spindle sticking upwards vertical. So yeah. So the worm wheel will be this blank. And that's what I mean, I need 8 TPI because it's going to be 60 tooth, and it needs to be fairly wide because I'm not going to have the bronze on the actual steel itself. I'm going to have like a steel bushing to go on, and then this is going to be on that bushing, and then there's a lock nut somewhere that goes on that thread. There it is. So if I design it, another good thing with it being so wide, if I design it with a recess in the actual gear itself, because you can see there's not a lot of thread there at all when it needs to be sticking out as far as it can, because obviously you're going to have the attachment coming down like this and you don't want it fouling this, so you need that wide thread. Need it to be about that distance, so I don't know how I'm going to design that yet, but it is in 3D software at the moment. It needs to be far enough forward for the spindle of the dividing attachment to be in line with the worm wheel, but it can't be. It's got to be far enough out so it's in alignment, but obviously far enough in so I can get that locking nut on. Also having a recess in this to be able to get that locking ring on. There's not a lot of diameter difference, so I'll work it out anyway. But that is going to be the worm. 1 inch 8 TPI, gorgeous.